In class, we learned this new property called the law of sines, and I went through a derivation of the law of sines from a triangle. I'm not going to repeat that here in this video. I'm just going to write out the law of sines, and then we're going to do some example problems. So hopefully you'll remember that the law of sines says that the sine of A over A equals the sine of B over B equals the sine of C over C. And to remind you about these parts, remember we had a triangle, and it's any old triangle. It doesn't have to be a right triangle. In fact, we prefer it not to be a right triangle. And if this is angle A, then this is side A. And if this angle B here, this is side B here. And if this is angle C here, this is side C here. And this particular equation, or compound equation, is true. And what we'll do is we'll use pairs of these to solve triangles. And by that I mean we are going to find all of the missing information from a triangle, which is only partially, a part of the information is given to us. So our goal is to find all of the sides, lowercase a, lowercase b, and lowercase c, and then all of the angles, capital A, capital B, and capital C. Okay, let's take a look at our first problem. So you can see here, this is problem number 7, and we're given some information. We are given that angle C is 49 degrees, 49.9. Angle B is 63.1, and this guy right here, this is actually side A, which is 14.4. What we don't know, and what we're going to try and find, is side B, side C, and also angle A. Now, angle A is the easiest to find because we already know two of the angle measurements. We know 49.9 and 63.1, so if you simply write out on your calculator 180 minus 49.9 minus 63.1, you'll get the value of that missing angle A. And I've already done that on my calculator, and it came out to 67 degrees. So angle A right here is 67 degrees. Okay, now to find the other missing pieces of information, we're going to have to set up our proportions using our law of sines. So you just work with two at a time. So for the first one, I'm going to work with A and B. So I'm essentially going to do this equation. Sine A over A equals sine B over B. And I already know angle A, which is 67, so I really mean sine of 67 degrees over the 14.4 that's listed for A. And then I already know that B is 63.1 degrees, so it's going to be a sine of 63.1 degrees over letter B. And I'm trying to solve for B. Now, one of the things I happen to know about proportions is that you can flip the whole thing over, right? We can flip both these over and it'll make our lives a little easier. So I'm going to go ahead and do that. And I'm going to do the old switcheroo this way. So B is actually on the left side of the equation. So I'll rewrite the proportion as B over sine of 63.1 degrees equals 14.4 over sine of 67 degrees. And to solve this, all we're going to do is multiply both sides by the sine of 63.1. I'm doing this all without actually hitting my calculator yet because I want to do it all at once. But when I multiply by the sine of 63.1 on this side, those cancel out. And I'll multiply by the sine of 63.1 over here. And then we're going to be able to calculate what B equals. And all I really have to do is type in 14.4 times sine of 63.1 degrees divided by sine of 67 degrees. And when you do that, you get 13.9509. And what I'm going to do is I'm going to round that off to an even 14. We'll call it 14 miles. Came out to 13.95. We'll round off to one decimal place, which is 14.0 miles. So letter B here is 14 miles. So I've solved for angle A. I've solved for side B. I need to solve for side C now. And as you can see, I filled up a lot of the screen. So I'm actually going to finish this one off on a new slide, and I'll just find letter C. So to find side C, I'm just going to run through that process again, but I'll use A and C instead of A and B. And so if I do sine of A over A, that's going to equal, oops, that should be lowercase a. Okay, we already know the sine of A is going to be the sine of 67 degrees. I know that side A is 14.4. I know that C is 49.9 degrees. Oh, that's a very bad 0.9 there. And I'm trying to find letter C. Again, I'll do the old switcheroo. And I'll end up with C over sine of 49.9 equals 14.4 over sine of 67. And again, I'll multiply both sides by this denominator, sine of 49.9. Cross those out, multiply over here. And I end up getting the value for C. I'm just going to compute this on my calculator. And that comes out to 11.96. So just like I did for the other one, I'm going to round that off to 12 miles. And I just use this little squiggly equal sign here. That means approximately equal to. So C is approximately 12 miles. So that's what we mean when we say solve the triangle. We're looking for all these missing parts. And we just went through this problem where you were given two angles and a side, right? We were given the 49.9, we were given the 63.1, and we were given the measurement of one side, and we found the other three missing pieces. I'll show you one more example where you're given two sides and one angle, and we'll solve that one, and then we'll be done with this video. So again, we're going to try to solve the triangle here. Notice we're given that angle A is 87 degrees, that side C, oh goodness, that side C is 20 kilometers. I'm having a terrible time with this little pen here. And side A is 28.2 kilometers. What we're trying to find are angle C, angle B, and side B. That's what we're trying to find. So we'll jump right in and we'll start with one of our ratios. Let's work with A and B, just for the heck of it. So we're going to do sine of A over A equals sine of B over B. And so we know that A is 87 degrees, so sine of 87 degrees over, the measurement for A is 28.2 kilometers. That's going to equal the sine of angle B. Oh, I can't do this one yet. I don't know angle B and I don't know letter B. So let's shift gears and we're just going to pull the old switcheroo here. I'm going to do C first on these. So sine of C over C. And I have to do that because I do not know either of the B measurements. I have to know 3 of the 4 spots, and I didn't know that one. So sine of angle C over 20 kilometers. This one I can do. Okay, so let's run through this thing. And in this problem, you're going to actually need a new tool. And I'll remind you of that when we get there. So the sine of 87 degrees. Let's see. I'm trying to solve for sine of C. So all I'm going to do is I'm going to pull the switcheroo on this one and write it like this. So this is sine of C over 20 equals sine of 87 over 28.2. And I'm going to multiply both sides by 20, and then we can crank this out in the calculator. But we won't be done yet because all we're solving for is the sine of C. So when we do this, I find out that the sine of C is whatever sine of 87 degrees divided by 28.2 times 20 is. And I'm going to calculate that now. It is 0.70825. I just rounded it off to 5 decimal places there. Let's just go to 4 decimal places. If I go to 4 decimal places, it's just 82. So we'll just leave it there because that 5 I rounded up. So it's really a 4 there. All right, now to solve for C, we actually need to use a different button on our calculator, which is an inverse sign. When you're solving equations, you use inverse operations to isolate the variable. In this case, we have to use something called inverse sine. There's a key on the calculator which will do this for you. So if you do inverse sine, which is the shift of sine, it looks like this, and you type in that 0.7082, it's going to pop out with your angle, and you'll be done. And we'll know what angle C is. So if I type that in on my calculator, here's what I get. And I'll just round this off to 1 decimal, so we'll make it approximately. We're approximately equal to, it says 45.08. I'm going to call that 45.1 degrees. So I had to use this little inverse trig function here on my calculator to figure out the angle. But once I get that angle, I can put that on the picture, right? 45.1 degrees. And now that I know the 87 and the 45, I can figure out the B just by subtraction. 180 minus 87 minus 45.1. That's going to give me my angle B, which is 47.9 degrees. All right, so that's angle B. So we didn't have to do any inverse trig functions to get that one. We just simply subtracted 47.9 degrees. So I have 87 degrees, 45.1, and 47.9. Now all I need to do is solve for little b right here. We still have to get the lowercase b, the side length of that side. So I'm going to start with a fresh picture, and I'll finish that one off, and then we'll be good to go. The last thing we have to do, as I mentioned, is solve for this side b. So now I can use a and b, and we can get this thing done. So I'm going to use this proportion. Sine of a over lowercase a equals sine of b over lowercase b. That's the law of sines. The numbers are going to be sine of 87 degrees over 28.2 kilometers equals sine of 47.9 degrees over letter B. Again, I've done this before. We'll do the old switcheroo just to isolate B. And end up with B over sine of 47.9 equals 28.2 over sine of 87. And I multiply both sides by that sine value. And again, we'll do this whole calculation on the calculator. These cancel out. And the measurement for side B is approximately 20.95. I'm going to round that off to 21. So when you crank it out on the calculator, round it off, 21.0, and that's kilometers. And we're done with this problem. B is 21.0 km. Okay, so we solved for the 3 missing parts of this triangle. We did have to use an inverse trig function on our calculator to solve for one of the angles. So just be aware that that could happen. And then we finished it off by solving for side B. So you've seen an example where you're given 2 angles and 1 side. And now you've seen an example where you're given 2 sides and 1 angle. Good luck with these problems. Let me know if you have any issues. You know where to find me. Take care.